Okay, so 3.3a, we're going to be doing inequalities. So we did solving inequalities with addition and subtraction in was it 3.1 and 3.2? Or was that all 3.2? I think it was all 3.2. So today we're going to do multiplication for 3.3a, and then we're going to do division for 3.3b. So those two are really, really similar in what you have to do. It's a little more complex than the addition and subtraction stuff, because with addition and subtraction, you did it just like you were solving an equation, right? Where there was an equal sign instead of an inequality. Now with this, you're not going to have that exact same setup. There is something else that has to change with multiplication and division. So I will show you right now what that looks like, just so you get a feel for how this is slightly different. So I'm going to start you with a number line, just to kind of illustrate the setup here. Let's say you have a number line, and this is totally up to you. I mean, this is part of just explaining to you what you're going to do with it. So if you feel like this would benefit you for your notes, go for it. I don't need you to write it. If you want to just watch, that's fine. Okay, here's the deal. I'm going to give you 2 points. 1 point at -2 and a point at 3. Okay, if I compare those two numbers, -2 and 3, which inequality would I put between them? Less than, greater than, less than or equal to, greater than or equal to? -2 is less than, 3, okay? What if I took those two numbers and I multiplied them both by 2? So I have a -2 and I multiply it by 2, and I have a 3 and I multiply it by 2. -2 times 2 is -4. 3 times 2 is 6. What inequality would go between those? Less than, greater than? Less than still, right? -4 is less than 6. -2 is less than 3, right? So if I multiplied by 2, it would put me at -4, and multiply by 2 over here, it would put me at 6, okay? If instead, I'm going to take those 2 dots away that I just put there. If instead we start with -2 is less than 3, and I multiply by a negative number. So now let's switch it up. I have my -2, I have my +3. If I take -2 and I multiply by -2, and I take 3 and I multiply by -2, what's -2 times -2? A +4. What's 3 times -2? A -6. So we started as -2 is less than 3, and we multiplied it both sides by a negative number. What symbol would go between my 4 and -6 now? Greater than, right? 4 is greater than -6. So if I multiply this -2 by -2, I end up here. If I multiply this 3 by -2, I end up here. Notice what happened? They leaped over each other, right? When you multiply by a negative number, it changes your setup. So if you multiply by a positive, your symbol stays the same. But if you multiply by a negative, what was less than becomes greater than. And what was greater than becomes less than, okay? That's the concept you have to be very careful with in this section. If you multiply both sides by a negative number, you have to flip your inequality the other way, okay? So that's what we're going to do. We're going to do some where it's not flipped and some where it is flipped, using multiplication and using division. So for now, we're going to do the multiplication. Yeah?
Can you do another one of these? I'm so lost.
Yes. So let's see. If I do, let's say you have 0, 1, 2, 3. Josiah, if you can't pay attention up here, you're going to move somewhere else where you can't look at anybody. So
My bad. Sorry.
point your head this way,
Yeah.
and we'll be great. Okay, so let's say we start with -1 and 2. What's the relationship between -1 and 2? -1 is what? What's the inequality? Less than, right? -1 is less than 2. But if I multiply both of them by -2, so -1 times -2 and 2 times -2, I get a positive 2. So this -1, when I multiplied by a negative, moved over to here. This 2 moved over here. Okay, so they jumped over each other, which changes their relationship to each other. So what was less than is now greater than. Okay, and I'll show you in an actual example of like what the problems are going to look like. I think it'll make more sense that way. But I just want you to see why we changed the sign. Okay, because you'll change your inequality every time you multiply by negatives. Okay, so let's just do a few to see what we're doing with these. Example 1 here, we're going to solve and graph. Get my ruler out. All right, let's say our problem is x over 3 is less than -2. Okay? How do you isolate your x? How do you get x by itself? You multiply by 3 on both sides. So if I multiply by 3 here, and I multiply by 3 here, these ones cancel. So I have x. Do I flip my sign? Did I multiply both sides by a negative? No, right? So your sign's going to stay the same. X is less than -2 times 3 is a -6. So that's your answer. And then you graph it. How do I graph that? A point at 6 is open or closed? Open at 6. And what direction is my arrow?
Left.
To the left. It's less than, right? Less than goes to the left. Okay, if I turn that into an arrow, right, my arrow's pointing to the left. Okay? Yes, ma'am.
So like, you know that like arrow thing where it's like if it's pointing one way, that's the way the arrow goes? I did that on a quiz. I didn't get it right. So is it just like when the variables on the left side?
If the variable's on the left, if your variable is first, x is whatever to some number, it always points the direction the arrow would be. So if it's this way, your arrow's going to point to the left. If your variable's here, then it's the opposite of what direction it would be. So like this, even though it looks like it's pointing to the right, your arrow would actually point to the left. So safest bet is just always put your variable first. Okay? Okay, what do you do with this one? Let's say it's c divided by 8 is greater than 1/4. Okay, so we want to isolate our variable. What do you have to do on both sides? Multiply by 8. So we're going to multiply by 8 here. We're going to multiply by 8 here. So our 8's cancel. Do I flip my symbol? No, because we multiplied by a positive. And then 1/4 times 8 would be 8/4, or if you reduce that, you get c is greater than 2. Okay, so that would be your answer. C is greater than 2. And then when you graph that, you put a point at 2, open or closed? This one's open. And what direction does my arrow go? To the right. Okay, questions on that? Okay, how about this one? We're going to call this example 2 because this is where we get more negatives coming into play. So x divided by -2 is less than or equal to 5. Okay, how do I isolate my x? multiply by -2 on both sides, okay? So the negative 2's cancel. Do I flip my sign? Yes, you need to flip your less than or equal to over to a greater than or equal to because we multiplied by a negative, okay? So 5 times a -2 is a -10. So you get x is greater than or equal to -10. So if this is my -10, is it an open or closed dot?
Close.
It's a closed dot because it has that equal to bar, right? And then what direction is my arrow going?
Right.
To the right, because it has to be greater than -10, okay? You only flip it when the number you're multiplying on both sides is a negative, okay? All right, how about this one? You have -3/4 times w is greater than or equal to 3. What do you do to isolate w, Damon? The other way, -4/3, right? When dividing fractions, don't ask why, flip the second guy and multiply, right? So you're gonna flip the 3/4, -3/4, and multiply by it. So you're gonna multiply by this to get these to cancel, and whatever you do to one side, you have to do to the other, okay? So this is gone. We're left with w on the left. What's my symbol gonna be? Less than or equal to, you gotta flip it around, right? Because we multiplied by a negative. And then you can think of this as 3/1 if that helps you, and then multiply straight across, or you can cross cancel. I feel like you guys usually multiply across. I like to cross cancel on this one because it's 3's. So I'll show you both ways. The 3's would cancel, right? 3 and 3 would be 1 and 1, so all you're left with is a -4. Or if you wanted to multiply across, 3 times -4 is a -12. 1 times 3 is 3, which comes out to a -4. Okay, so either way, this is what you get. Is that going to be an open or closed dot? Closed dot, arrow to the left, okay? And we're not actually going to graph that because we've graphed a bunch. Any questions on that idea? When do you flip your sign? When you multiply both sides by a negative, okay? Not if one side has a negative on it. When you multiply both sides by a negative, okay? Okay, that's the first half. That's 3.3a. Do you want me to keep going on to 3.3b, or do you want to take a break and try it out a little bit? Video then. But we'll start fresh here so you know where the break is in your notes. So this is 3.3b, and this is solving inequalities with division. Oops. Okay, here's the beauty of it. I'm not really teaching you anything new in this lesson. It's the same rules as multiplication, okay? So when dividing, if you divide by a positive number, are you gonna keep your symbol the same or flip it? Same. If you divide by a negative number, are you going to keep it the same or flip it? Flip it, okay? So that's the only rule that really matters. It's just now you're dividing instead of multiplying, okay? Which I feel like most people think is easier than the multiplying one because it looks like fractions and it just kind of freaks people out sometimes. So starting with, we're just going to keep going. So example 3, if I said solve and graph, and I got this set up. 6D is less than or equal to 42. Okay, take a look at that. What would you do first? Yeah. Divide by 6 on both sides, right? We're trying to isolate the D. So you're going to divide by 6, divide by 6. So these are gone. Do you flip your inequality? No, right? You divide it by a positive, so it's going to stay the same, less than or equal to. And what's 42 divided by 6? 7. Okay. Oop. So D is less than or equal to 7. throwing things on the floor. So if we graph that, here's my 7. Is it open or closed? Closed dot. And what direction do I put my arrow? To the left. We're going to go less than or equal to. Okay. All right, next example. This one's a word problem, so we're going to see if you can help me set it up. It says, you walk dogs after school. We're not going to write that part out. You earn $4.50 per dog that you walk. Okay. The question is, how many dogs do you need to walk to earn at least $75? Okay, so you earn $4.50 per dog. You want to make at least $75. Anyone think they can set up an inequality for me? What do you want to call dogs? D. I like D. So D is going to be our dogs. How do you set up an inequality? If it's $4.50 per dog. I missed in all the hacking going on over here what you said after the 450.
You do like 450
D, right. Yeah, so 450 times the number of dogs, okay, and you want to earn at least. And I feel like this at least throws so many people off because they think less than, right? But if you want to earn at least, then that 450D has to be greater than or equal to 75. Okay, so good job on that, Bella. What do you do to solve that? You divide by 450. So if I divide by 450, 75 divided by 450, I'm left with D. Do I flip my sign? No, leave it the same because we divided by a positive. And you get 16 2/3. Okay? The question was this: how many dogs do you need to walk to earn at least $75? What's your answer? 17, right? Because can you walk 2/3 of a dog? No. You like leave his butt home or something? So because you got 16 2/3, even if it was 16 1/3, right? If it was 16.1, you can't do 16. You're not making enough. You have to do a bit more than 16, so then you round up to 17, even though technically that's not how you'd round. So you need to walk 17 dogs. Okay, when I ask you for an answer on word problems like this, I want you to tell me in a sentence. I want you to explain to me what it means, because when you just give me this, that doesn't tell me that you know anything about it, right? I want you to tell me, okay, well, I have to walk at least 17 dogs to make my $75. All right? All right, last type of problem. There's 3 of these, and then we're done. Let's say you have negative 9y is less than or equal to 63. Okay? What are we going to do to solve that problem? Yeah, Damon. Divide by what?
-9.
Right. So if I divide by -9 here and I divide by -9 here, my negative 9's go away. Do I flip my symbol?
Yes.
Yes, because you divided by a negative, right? So it's greater than or equal to, anyone knows 63 divided by -9 off the top of your head? -7. Okay, so that would be our answer. And then to graph it, here's your -7. Open or closed? Closed. And then arrow to the right. right? If I turn that into an arrow,
Oh, that's right.
your arrow goes to the right.
Right.
Okay?
Right.
Quit. Quit. Be done. Whatever's going on there, pay attention here. All right, what about this one? Negative 3x is greater than negative 9. What do?
You divide by -3.
Right, divide by negative 3. Okay, so those are gone. Do I flip it?
No. No.
Yeah. Yes, because of negative.
I divided both sides by a negative, right? So you're going to flip it over. And what's negative 9 divided by negative 3? Positive 3. So x is less than 3. So here's your 3. Open or closed? Open, right? And then less than goes to the left. So it would look like that. Okay, last one. You guys are going to have a lot of time.
Go home, right?
Yeah.
Oh, yeah, we do.
You get out at 11:15. Okay, so if this is your problem, 5y is less than negative 45. Am I looking at the wrong day?
Yeah.
Oh, I'm looking at odd, even. Sorry. You get out at 12:10. 12:10. Okay, what do you do to solve?
You divide by 5.
You divide by 5. Okay, so this is a y. Do you flip?
No.
No, but I will tell you right now, this is where most people make the mistake because they see a negative in the problem, so they think, I got to flip it. You only flip if the negative's down here, okay? So don't let that other negative throw you off. So divide by 5, you get y is less than, what's negative 45 divided by 5?
Negative 45 divided by 5 is...
Negative 9. Okay, so then to graph it, here's your negative 9, open or closed?
Open.
Open to the
Right.
left. Turn it into an arrow. You go left. Okay? Questions on that?
Good.